Everyone, this is lesson 8, and we're going to do some problem solving. And one of the things that we use a lot when we're talking about problems in trigonometry or geometry is we talk about an angle of elevation and an angle of depression a lot. And our little airport example here is you've got people in a tower looking up to people in a plane. You've got people in a plane looking down to the people in a tower. So the people in the tower that are looking up, they're looking up, so it's an elevation, and the people in the plane are looking down, so it's an angle of depression. The thing is, though, that if you're looking up at somebody and they're looking down at you, these angles are equal to each other. So if we said the angle looking up is 20 degrees, the angle looking down is 20 degrees. If the angle looking up is 30 degrees, the angle looking down is 30 degrees. So that's kind of some other mathematical properties that kind of relate as to why those angles are equal, but it kind of makes sense if you think about it. So in our first example here, I'm just going to change screens so we do some work. In our first example, we have an angle of depression in our story. So you're 32 meters from 32 meters is the height of the lighthouse. The angle of depression is 29 degrees. What's the distance from the boat to the lighthouse? So when seen from a 32 meter high, so from a 32 meter high lighthouse, so I'm going to say for my triangle, that's from B to C, it's 32 meters high. The angle of depression is 29 degrees. So the angle of depression is 29 degrees. But 29 degrees is not in my triangle. So I go over here where my angle A is, and that's where the boat is. So the angle of elevation is 29 degrees. So because the angle of depression is 29 degrees. So inside my triangle, I've got 32 meters for the height and 29 degrees. I want to determine the distance from the boat to the lighthouse. So from the boat to the lighthouse, what distance is that? That's from A to C. That's where I'm going to put my X. So if you're not given the information on a triangle, lots of times you have to start off by making your triangle. Then we want to always label our triangle properly. 90 degrees projects over here to the hypotenuse. The angle I'm talking about is 29 degrees. My 29 degrees projects all the way across here to my opposite. And then where my X is, it's going to be the adjacent side. So like we did in our other problems, when you're given a triangle, we want to know what is the best ratio, sine, cosine, or tangent to work with. So if we start writing out ratios, like we did at the start of the chapter, we used the words. Later on in the chapter, we used an acronym, SOHCAHTOA, and then based on what's in our triangle, we can figure out what ratio to use. So again, I'm going to show lots of work. Sine ratio, sine of 29, because the 29 degrees is opposite 32 over hypotenuse. I don't have anything here for my hypotenuse, so I'm just going to call it C because it's opposite the C. Cosine is adjacent over hypotenuse. Again, cos of 29 degrees. Adjacent is X, and hypotenuse is still C because there's nothing here. And then tan of 29 is opposite and adjacent. So tan of 29 is 32 over X. So I'm looking at my three ratios. I know I'm going to work with my tangent ratio then to solve my problem, right? So tangent is the one that I'm going to work with. That's the information that's given to me. So the next thing I do then, solve my problem, is I change tan 29 into a decimal, and then I just cross multiply. 32 times 1 divided by 0.5543, and then I find X is 57.7. And I don't know if it's set to solve to nearest tenth or nearest one decimal place or nearest meter. I have to go back and check what it says. It didn't say anything. So on your assignments, we talk about rounding things off to one decimal usually, or rounding things off to the nearest whole number. So that's an example then of solving with an angle of depression, which is the same thing as saying an angle of elevation.